NASA's always on the lookout for possible asteroid collision hazards. So the Pan-STARRS telescope is scanning the sky every night. Each morning, candidate objects are examined by Pan-STARRS staff and usually discovered to be no big deal. But on October 19th, 2017, Pan-STARRS spotted an object moving rapidly between the stars. And this time, the usual follow-up measurements of position and speed showed something completely different. By October 22nd, we had enough data to realize that this object wasn't from our solar system. Holy cow, that's when I got the phone call that all solar system astronomers are waiting for. Let me tell you how exciting this was. NASA's been expecting to see an interstellar comet pass through the solar system since the 1970s, but until now, we'd never seen anything. Our own solar system is huge, so even getting a package from the nearest star system, 4.4 light years away, would take over 50,000 years. So this is a really big deal. The interstellar visitor entered our solar system from above the plane of the planets, coming from the direction of the constellation Lyra, and it passed closest to the Sun on September 9th, passing inside the orbit of Mercury. Now, this isn't a particularly close approach or unusual distance. It's just much easier to see objects close by. On October 14th, before we discovered it, it made its closest approach to the Earth, within about 15 million miles. This is really close by astronomical standards. Now, rather than call this by its unwieldy catalog name, we briefly called it Rama, after the cylindrical spacecraft that passed through the solar system in Arthur C. Clarke's classic science fiction story in 1973. But this wasn't quite right either. So in honor of it being discovered by a telescope in Hawaii, we consulted two experts on Hawaiian culture, a Hawaiian navigator and a linguist, to propose a name. And they suggested Oumuamua, which means scout or messenger from the distant past reaching out to us. Now, this discovery was important for many reasons, but to me the most significant is for what Oumuamua can tell us about the past of our solar system. The process of the birth of a new solar system and the growth of planets can be a violent and messy business. Leftover icy and rocky debris gets ejected from the new solar system as the giant planets migrate through the dusty disk out of which they're formed. Now, have you ever felt an emotional chill? Something that's so exciting that a shiver runs up and down your spine? Or something that's very emotionally moving? Well, this was it for me. This was my wow moment. We actually had a piece of material from another solar system coming close enough for us to observe. So what would you like to know about Oumuamua, the very first visitor from another star system? Well, I could think of a million things, but there's what you want and what you can have. And Oumuamua was moving away and fading very rapidly. In the span of about a week, it had dropped in brightness by a factor of 100. So this is about all the time we were going to have to study it easily. So we had to distill the process of getting telescope time, normally a very competitive peer-reviewed proposal process that can take up to months, down to less than a few days. So began a polite competition for resources. Okay, let me not mince words. It was a fierce battle. We dropped everything, working around the clock, trying to craft perfectly crafted proposal words to send to the observatory directors. Well, good news, we got the time. Now, from a perfectly selfish point of view, the first thing we might like to know is how massive Oumuamua is. Because after all, it passed very close to the Earth, and we didn't know about it until afterwards. How bad would this have been had it not missed the Earth? Well, the impact energy depends on the square of the velocity times its mass. And the mass depends on how big it is and what it's made of. So how big is Oumuamua, and what's its shape? Well, we can get this from its brightness. Now, if you don't believe me, think of comparing the brightness of a firefly in your backyard to the airplane lights, navigation lights on a distant airplane. You know the airplane is much brighter, it just appears faint because it's so far away. We're also going to need to know how reflective the surface of Oumuamua is, and we don't have any clue. But it's reasonable to assume it's very similar to small asteroids and comets in our solar system, or in technical terms, something between the reflectivity of charcoal and wet sand. Nowadays, most of the big telescopes are used in what's called a service mode, meaning we have to carefully develop all the instructions and send them to the telescope operator, and then anxiously wait for the data to come back, praying to the weather gods. Now, I bet most of you don't have careers that critically depend on whether or not it's cloudy last night. Well, we weren't going to get any second chances here. Because the weather was great, Oumuamua decided not to be. Its brightness wasn't constant. Now here we see Oumuamua racing between the stars. It's centered in the middle. The stars are trailed out because the telescope is following its motion. It started faint, and then it got brighter, fainter, brighter, and fainter again, as sunlight is reflected off of four sides of an oblong object. The extreme brightness change led us to an unbelievable conclusion about its shape. As shown in this artist's impression, Oumuamua is apparently very long and narrow, with an axis ratio of about 10:1. Assuming it's dark, this means it's about half a mile long. Nothing else in our solar system looks like this. We only have a handful of objects that even have an axis ratio bigger than 5:1. So we don't know how this forms, but it may be part of its birth process in its home solar system. Well, Oumuamua was varying in brightness every 7.34 hours, or so we thought. As more data started to come in from other teams, they were reporting different numbers. Why is it the more we learn about something, the harder it gets to interpret? Well, it turns out that Oumuamua is not rotating in a simple way. It's wobbling like a top. So while it is rotating around its short axis, it's also rolling around the long axis and nodding up and down. This very energetic, excited motion is almost certainly the result of it being violently tossed out of its home solar system. Now, how we interpret the shape from its brightness depends very critically on how it's spinning. So now we have to rethink what it may look like. And as shown in this beautiful painting by space artist Bill Hartman, we think that Oumuamua may be more of a flattened oval. So let's get back to the energetics. What is it made of? Well, ideally, we would love to have a piece of Oumuamua into the laboratory so we could study it in detail. But since even private industry can't manage to launch a spacecraft within a week to something like this, astronomers have to rely on remote observations. So astronomers will look at how the light interacts with the surface. Some colors may get absorbed, giving it a chemical fingerprint, whereas other colors may not. On the other hand, some substances may just reflect more blue or red light efficiently. In the case of Oumuamua, it reflected more red light, making it look very much like the organic-rich surface of the comet recently visited by the Rosetta spacecraft. But not everything that looks reddish has the same composition. In fact, minerals that have tiny little bits of iron in the surface can also look red, as does the dark side of Saturn's moon Iapetus, shown in these images from the Cassini spacecraft. Nickel iron meteorites, in other words metal, can also look red. So while we don't know what's on the surface, we know even less about what's on the inside. However, we do know that it must at least be strong enough to not fly apart as it rotates, so it probably has a density similar to that of rocky asteroids, perhaps even denser, like metal. Well, at the very least, I want to show you one of the beautiful color images that we got from one of the ground-based telescopes. All right, I admit it's not all that spectacular. We just don't have the resolution. Even Hubble Space Telescope doesn't present a much better view. But the importance of the Hubble data was not because of the images, but because it extended our observations out to 2.5 months from the discovery, meaning we get more positions along the orbit, which will hopefully let us figure out where Oumuamua came from. So, what exactly is Oumuamua? We firmly believe it's likely to be a leftover archaeological remnant from the process of the birth of another planetary system, some celestial driftwood. Some scientists think that maybe Oumuamua formed very close to a star that was much denser than our own, and the star's tidal forces shredded planetary material early in the solar system's history. Still others suggest that maybe this is something that formed during the death throes of a star, perhaps during a supernova explosion as planetary material got shredded. Whatever it is, we believe it's a natural object, but we can't actually prove that it's not something artificial. The color, the strange shape, the tumbling motion could all have other explanations. Now, while we don't believe this is alien technology, why not do the obvious experiment and search for a radio signal? That's exactly what the Breakthrough Listen project did, but so far Oumuamua has remained completely quiet. Now, could we send a spacecraft to Oumuamua and answer this question once and for all? Yes, we do actually have the technology, but it would be a long and expensive voyage, and we would get there so far from the sun that the final approach trajectory would be very difficult. So I think Oumuamua probably has many more things to teach us, and in fact there might be more surprises in store as scientists such as myself continue to work with the data. More importantly, I think this visitor from afar has really brought home the point that our solar system isn't isolated. We're part of a much larger environment, and in fact, we may even be surrounded by interstellar visitors and not even know it. This unexpected gift has perhaps raised more questions than it's provided answers, but we were the first to say hello to a visitor from another solar system. Thank you.